Hello and welcome to the Bearded Mathman's YouTube channel. Hey, this is part 2 of Special Right Triangles, and it's in our series on trigonometric fundamentals to get you a rock-solid foundation so that whenever you face any issues involving trigonometry, you don't only know what to do, you know why. So let's go ahead and get into it, shall we? What we're going to be doing is we're going to be using the special right triangles, the properties of these two special right triangles, to solve triangles, to figure out values of sides and angles that aren't exposed. So like, for example, this is an isosceles right triangle. So whatever the hypotenuse is, the sides are that times the square root of 2 over 2. And this is a 30, 60, 90 right triangle. And I know that it's a 30, 60 right triangle because the relationship between the hypotenuse and the short side, who's at the short side, is half of the hypotenuse. And the long leg is the square root of 3 times the short side, or the hypotenuse times the square root of 3 divided by 2. And so this is a 30, 60, 90. So we're going to use those two properties to help you answer the questions like the ones that were posted in the previous video. So if you had trouble with those questions, this video might really help unlock it for you. So let's go ahead and get into one of the examples specifically. So this is a no calculator type problem. And what we have to do is we have to apply what we know about special right triangles to figure out the angles and the side. Now, if you do an internet search for special right triangles, you're going to find diagrams like this on the left most often. But I prefer this one on the right. It might be a little harder to set up initially, but where we're going with this trigonometry, this kind of example, which is what I share in the videos here, makes much more sense. Now, if you want to see where I got these two pictures off the internet, I will post links in the description below. I also will post a link to my webpage where you can find notes and practice problems, other videos, and all kinds of stuff trig related or any kind of math that's high school related on the website, thebeardedmathman.com. But anyway, let's see how we can apply these shortcuts to figure out the missing parts of this triangle. Now our clue is the square root of 3. Now we have to be careful. We have to make sure that everything else works. But this square root of 3 happens to be something that comes out of a 30, 60, 90 right triangle. And so the relationship between this long side right here and this short side has to work. Otherwise, we're not sure if this is really a 30, 60, 90 right triangle. So when I look at this diagram right here, I've got the square root of 3 over 2 is the long leg, and the short leg is half. And so if I take the short leg and I multiply it by the square root of 3, then I should be able to get the long leg. So if I take the short leg here, 7, and I multiply it by the square root of 3, well, that is a long leg. So this is, in fact, a 30, 60, 90 right triangle without doubt. Now, the next trick is to figure out, where's the 30 go? Where's the 60 go? Well, thing that's true about triangles is the shortest side, which is the 7, is going to be opposite of the smallest angle, which is 30. So the 30-degree angle is going to go there, and the 60 is going to go here. Now, it's very, very important that you understand why the 60 is here. The reason why is 60 is the biggest angle, other than 90, of course, right? 60 is the biggest angle, and it's opposite of the largest side, the longest leg. And the 30-degree angle is the smaller angle. It's opposite of the shortest side. So you can't mix those up. You really got to understand why it is that way. Now, let's see if we can go ahead and set up an equation to help us find the hypotenuse. Here's what we know. We know that the short side, which is 7, is whatever the hypotenuse is divided by 2. So it's half, right? So if we set up this relationship right here and we plug in values that we're given, well, then we can solve this. So since I know the short side is actually 7, then I know 7 is the hypotenuse divided by 2. If I multiply both sides by 2, I see that the hypotenuse is, in fact, 14. There we go. Now, let's say we had the same exact type of situation, but now we were provided an angle and a side. Well, we'd have to recognize that this is a 30, 60, 90 right triangle, and that whatever the hypotenuse is, the long leg is that times the square root of 3 over 2. So whatever the hypotenuse is times the square root of 3 over 2 is what the long leg is going to be. We happen to know the long leg is 7 root 3, so we're going to go ahead and plug that value in, and we're going to use that information to solve for the hypotenuse. Now, this might look a little tricky. We're dealing with irrational numbers here, and arithmetic with irrational numbers, yeah, it is a little tricky, but all we got to do is multiply both sides by the reciprocal, and look at this. That's 7 times the square root of 3 over 1, of course. So the square root of 3 divided by the square root of 3, well, that just reduces to 1, and you end up with 14. So it was the exact same triangle, but just a slight variation of the information provided. Now let's see one more example. In this one, it tells us it's a 30, 60, 90, but one of the side lengths involves the square root of 2, and that square root of 2 might make you think instantly, oh, this is isosceles. But no, that would not be the case. The hypotenuse is 8 times the square root of 2, and it tells us that it's a 30, 60, 90. So just because you see a square root of 3 does not automatically mean you have a 30, 60, 90. And just because you see a square root of 2 doesn't mean you have a 30, 60, 90 or a 45, 45, 90. You have to make sure that all the relationships hold true. Here it tells us it's a 30, 60, 90, and the hypotenuse is 8 root 2. So let's go ahead and set up our information that we know. We know for an isosceles, or for a 30, 60, 90 right triangle, we know that the hypotenuse times the square root of 3 over 2 is going to be equal to the long leg, which is b right here. So the hypotenuse times the square root of 3 over 2 is the long leg. And we also know that whatever the hypotenuse is divided by 2, or times 1/2, is what the short leg is, and that's a. So the hypotenuse we know is 8 root 2, so we're going to plug that value in, and we're going to use that to simplify this to see what the long leg is. Now we have to multiply these. Square root of 3 times the square root of 2 is square root of 6, and the 2 divides into the 8 to make 4, so our long leg is 4 root 6. Now let's do the same thing to find the short leg. We know the hypotenuse is 8 root 2. We know the short leg is half of that, so half of 8 is 4 root 2. Now let's see a couple examples with a 45, 45, 90. So this is the isosceles right triangle. So let's say we had a triangle that was marked like this. Now nothing's written as these being the same, these legs being the same, or the angles being the same, but because of those marks, we know this is an isosceles right triangles. We know that these two angles are going to be the same. Since that's 90, these two have to add up to 90 and they're the same, so they're both 45. So this is a 45, 45, 90 right triangle. We're given that the hypotenuse is 13, and we're going to have to figure out what these two sides are. So we know that the sides are the hypotenuse times the square root of 2 over 2. We know the hypotenuse is 13, so all we got to do is plug 13 in. 13 times the square root of 2 over 2, and that's it right there. Typically, we're not going to write 13 times the fraction square root of 2 over 2. We would typically write 13 times the square root of 2 quantity divided by 2. That's a little simpler to deal with, easier to do arithmetic with, and things along those lines. However, if you left your answer like this, it's probably perfectly okay. Let's see one more example involving an isosceles right triangle. Let's say we had an isosceles right triangle, and we knew that one of the legs was 5 times the square root of 3. Now you might be thinking, oh, that's got to be a 30, 60, 90 because of the square root of 3. However, look, it's marked that it's isosceles. So this is a 45, 45, 90. Because it's a 45, 45, 90, we know that the same relationship is true. The sides are equal to the hypotenuse times the square root of 2 over 2. We happen to know that the side is 5 root 3, so all we got to do is plug that in and then solve for the hypotenuse. The hypotenuse is times root 2 over 2, so we have to multiply both sides by the reciprocal, and then we're going to be done. This over here reduces, right, to just 1. So the hypotenuse is going to be equal to 10 times the square root of 3 divided by 2. Now that's an irrational denominator. We want a rational denominator, so we're going to rationalize it by multiplying by square root of 2 over 2. Square root of 2 times 2 is 2. Square root of 2 times the square root of 3 is the square root of 6, but we can still reduce that 10 and 2 to be 5 root 6. So the key idea is you have to first identify, if you're not using a calculator, most likely the triangle is going to either be a 30, 60, 90 or a 45, 45, 90. You have to identify which one it is, make sure you know, and then just set up your equation and then solve it and you're done. So here's the practice problems. Once again, you can try. I will put a link in the description below to my website where you can find all of this stuff and notes and wonderful things. It's going to just make life glorious and fantastic for you. It is thebeardedmathman.com. Hey, if you found this video to be helpful and useful, give it a thumbs up, subscribe, share it with other people that might find it to be useful on social media. If you have questions, comments, gripes, concerns, whatever, leave me a comment down below. I'd love to hear from you. And once again, I hope this has been helpful and useful. Be patient with yourself. Make sense of it. Give yourself time. Don't rush. It's going to make sense. life will be a lot easier for you in math class. Have a good day.